Welcome to secondary steel making course. Today I am going to introduce unit 3, which broadly covers tundish metallurgy part. The other thing is remelting process. Within the tundish you can modify the inclusions, you can allow the inclusions to float out and remove, and you have a chance to, within this particular last vessel technique, you can produce clean steel. After primary steel making, as a part of secondary steel making, before continuous casting, we use tundish. In the tundish, it is made possible to produce the clean and quality steel. The other part, it covers remelting process. Remelt the either steel scrap or in the form of electrode to produce steel is nothing but a refining process. If you do it under vacuum, it is vacuum arc remelting, where predominantly you use arc. And another thing is, if it is done in atmosphere by using electroslag as a reagent and producing the arc remelt is nothing but refining to produce quality of steels, variety of steels. These things are going to be covered in this part. Now let us know what is tundish, where it is located. This is the ladle. After primary steel making, the steel is taken into the ladle. This liquid steel is filled. This liquid steel is poured through this particular sliding gate through shroud into the tundish vessel, and within the tundish vessel you have a container which resides. You can modify the inclusions, you can add the allying additions, you can you can send the inert gas to get the homogenizing chemical composition. And this particular part is submerged entry nozzle, is nothing but SEN. Using this particular passage, it is being moved to the continuous casting molds. The continuous casting processes consist of molds. After the mold, you will be having the continuous rolls to straighten and to produce billet, bloom and slabs. That mainly we talk here about tundish, different tundish designs. This tundish design is a single strand design, and it is made possible. You can have this continuous casting mold multiple 1, 2, 3, 4, and from this particular liquid steel ladle you are taking out, storing in the tundish vessel, and you can produce continuously using the continuous casting mold multiple. Instead of this one, you can have 2, 3, 4 by this particular 4 strand, which looks like delta shape. And another point to be emphasized, that it has lined, predominantly MgO based working line is given for this tundish vessel. Now let us know about tundish process. Broadly it is called as the tundish metallurgy. What is tundish? It is a shallow and refractory lined vessel. And what are the functions of tundish? There are many. And what are the important aspects one need to cautious about tundish process or tundish metallurgy? These things will be covered here. This tundish function, it functions as reservoir to flow liquid steel to the continuous casting mold. It has provision to, you can float out the inclusions, you can modify the inclusions while residing the liquid steel within the tundish, and you can adjust the deoxidation. You can do desulfurization by adding the CaO. You can allow the deoxidation and covering with this particular tundish cover, and you can modify the inclusions. You can add some alloy compositions if you want to add some other alloying addition, tungsten, molybdenum, you can do it. And temperature control and homogenization mainly acquired by argon gas stirring within the melt of tundish vessel. And important aspects one need to be more cautious about, it reduces the heat loss. So it means you need to have the ladle furnace to increase again that particular temperature. And proper control of steel superheat is very crucial while coming out the tundish metallurgy liquid steel to continuous casting in the successive continuous casting. Avoid tundish skull formation at the mouth of the tundish vessel. The liquid steel should not get solidified. Avoid this particular skull when you are changing the one ladle to another ladle. This particular step need to be taken care. And grade changing, intermixing and changing from one ladle to one ladle, one need to be very cautious. It need to be covered with a tundish cover, and the slags which are formed need to be continuously removed and sending the continuously argon gas and allowing to stir it. These things need to be taken care. These are the important aspects. Now let me talk about few more tundish designs. For example, if the slag casting need to be produced, what kind of designs are practiced? Two different slag casting tundish vessels are shown here. This is a dummy metal. It is varied depth, and this is one particular slab, and this is another slab, concrete slab, and pillar is made within the tundish vessel, so that this is, and this particular thing, dam 1 and dam 2, this particular steel within the tundish vessel, it restores another reservoir and another reservoir. And you can use this kind of floating rods, higher melting point rods. It can float, so that you can control the float and produce different capacity of slabs. This particular tundish vessel capacity is 37. Capacity and volume and size, the thickness of the tundish vessel is very important. In another capacity of tundish vessel, it is you will be using this particular shroud. Above this particular shroud there will be a ladle. From the ladle the liquid steel is steamed, allowed to pour through shroud into which is refractory lined, and using pouring box which is ceramic box, and you after filling in the box it will fill the entire vessel, and you can use one dam only. After filling it, it will be flowing to this direction, it will be stopped. This is another reservoir, and you can use directly a ceramic type of stopping rod before going into the mold. That is another design, and which has the capacity of 28 ton capacity. These things one need to understand. Many designs are existing, depending upon whether you want to produce billet, the cross section is square, and whether you want to produce bloom, the cross section of this particular long length bloom is rectangle. For slab, which is flat shape, from the slab you can produce this particular thin sheets. From the billet you can produce rods and wires. From the bloom you can produce train tracks from the bloom. And the other part is, how do you measure how much was the depth of the steel after completely filled tundish? You will stop the ladle, the above ladle, this is the shroud, above the shroud. You use the laser light, it can be slide, you can keep it here and there, you can have the slide motion control. You can measure this starting point and other ending point. You can measure what was the depth, and as it has been continuously moving, it need to be maintained continuous depth. For example, this much depth need to be maintained. you will be maintaining, so that there will be a very less defects, you will be getting the quality casting products. This is also another point. This is another design which was used, and you can move the ladle also, ladle sliding gate. You can close the from the ladle flow also, you can close once it has been filled. That is another mechanisms which are kind of development which took place, which are in the practice in the modern industries. And flow control devices, many devices are used. This A is sliding gate. You can use this refractory type sliding gate. You can close since it is completely empty. When it is been empty, you will close it, so that you will allow in the continuous casting mold to getting solidified with the directional solidification, and you can stop it. And you can use this particular mechanism motor, the continuous stopping rod within the tundish. You can stop. This is SEN, submerged entry nozzle, which is going into the continuous casting mold. You can stop. Either of the design is being preferred depending upon you want to produce billet and bloom. This is for the billet process, this is for the bloom. Use the other process was the previous process used for the slab production, and these are the designs which are in practice. Now one need to know that is there any temperature effect with respect to the time. This residing time within the tundish also, it is so long time. You can do many of the treatment. You can add the allying addition, you can modify the inclusions, you can allow the inclusions to float up, you can remove the oxidizing products in the form of CO gas, sulfides, MNS and CS form. Many of the things you can do within this tundish. For example, if you see just after the ladle liquid steel is been poured, it was the temperature around 1620 degrees Celsius temperature. As you are taking out to the mixing the alloys, mixing the fluxes, the temperature drop down to 1540, and for again increasing the temperature you will use ladle furnace. The ladle it has been given the connection to the ladle furnace. This particular tundish is kept in the ladle furnace. By closing the sliding gate, and you will be preparing for the temperature drop downs. You are again heating, and you can allow the alloys to mix properly and fluxes. You can do desulfurization and carbon addition. If you want to add the carbon, if you want to add another alloying additions, you can do it, and you can trim that particular, you can control, you can homogenize, you can do some of the alloying additions. For example, for the deoxidation, you can feed aluminum wire feeding, so that you can allow for the deoxidation during the ladle furnace treatment. Then after you see the temperature drop downs within this particular ladle furnace temperature, it was around 1540, it has been increased to around 1580 degrees Celsius temperature, and when it is being moved to the continuous casting mold, it is 1540. And after allowing within the tundish, argon stirring and closing the tundish cover, it is increased to 1550 temperature. That is sufficient enough to pour into the casting molds. It will take this much amount of time. At the ladle, it was around 0 minute time, and when it is moved to the ladle furnace treatment, 20 minutes time, and about to go to the continuous casting mold within the tundish, it will be coming to around 80 minutes time. After 120 minutes, it is the temperature is about 1550 degrees Celsius temperature while pouring into the continuous casting mold. If somebody is asking that what is the effect of temperature and time within the tundish, one need to draw this diagram and explain all these particular points, whatever I told point by point. Now state that is it true or false in the last vessel such as tundish tundish, there is a chance exists cleaning of steel is made possible. Is it true or false? Give your opinion as the true or false statement.